Radiometric dating is one of the really handy uses of radioisotopes. So what happens if you have a collection of radioactive isotopes? They will decay, so they'll emit their radiation, and then that will change them. They'll change into a non-radioactive form, and they do this over a period of time. So in fact, when we talk about radioactive isotopes decaying, we talk about a half-life. So if we have a whole bunch of radioactive material, then in a period of time, half of it will have decayed and you'll be left with half. And then in the same amount of time that it took half of that first bit to go, half of the next bit will go. And then the same amount of time again, half of that next bit will go again. So these are called, they're called half-lives. So this is a graph of a half-life. So if I have, one amount of a radioactive isotope, I could have a kilogram or something. In one half-life, half of that material will be left. So it would be 500 grams. And then in another whole half-life, so when we get to two half-lives, a quarter. So half of a half would be left. And then again, another whole half-life, half of that would be left. And then, so an eighth. And then in another half-life, there'd be a 16th left. And then another half-life, there'd be 1/32th left. And then in another half-life, there'd be 1/64th left. So these graphs travel a long way as less and less of the radioactive material is left. And it's half the amount every single half-life. But this is useful because we can actually date things by looking at how much is left. So different radioactive isotopes have got completely different half-lives. So I've got strontium here. The half-life of strontium is 28 years. So if we know that if we found an amount of strontium, then it might be 28 years ago that there was the original amount. Cesium's got a half-life of 30 years. Plutonium's 24,000 years. Cesium 135, 2.3 million years. Carbon 14 has actually got a half-life of, I think it is 5,730 years. So by looking at the amount of carbon, in fact the proportion of carbon-14 decays to nitrogen, but by looking at the amount of carbon in living things, and all living things have a bit of carbon-14 in them, we can then deduct pretty much precisely when that thing was alive. So radiometric dating uses these half-lives of radioactive isotopes, and then we can use that to tell us how long ago things were existing on Earth.